Okay, so now video on titration calculations. If you remember from the previous video, the reason you do a titration is when you're trying to calculate an unknown concentration. So essentially, virtually every single titration question will give you information about two solutions. There's one solution where you know the concentration, and there's one solution where you don't know the concentration. And you just need to work out, so there's three things about each one. So remember the equation, concentration equals moles over volume, and then for the unknown one, concentration equals moles over volume. They will definitely tell you, your known concentration one, they will tell you, you'll know the concentration of one solution and you'll know the volume of it. And for the unknown one, you need to calculate the concentration, you know the volume, but you can't work out the concentration until you know the moles. So that's like part A of the question, if you like, and that's part B. So you go over here, you use this equation, so you rearrange it to work out moles. So you get concentration times volume equals moles. Do not forget the volume, you have to turn it from centimeters cubed into decimeters cubed. It goes the same for that volume over here. Should be the very first thing you do in any question. Before you do anything else, find the centimeters cubed, divide them by 1,000 and write them down as the decimeters cubed. Right. So so they told us the concentration of volume. We've worked out the moles. Ding! So we know the moles now. Then you use your balanced equation, which again they will give you in the question. You use the balanced equation, and that lets you work out the moles of the unknown one. Let's say, for argument's sake, it was A plus B makes C. And let's say that solution A is this one, and solution B is that one. So we've worked out, the question gave us the concentration of A and the volume of A. We've used it to work out the moles of A. We come down to our equation. There's no big numbers here, so it's just 1 plus 1. So if we had 1 mole of A, we'll have 1 mole of B. Or if we had 2.7 moles of A, there would be 2.7 moles of B, because the ratio is 1 to 1. Just going to randomly change this equation for a second. Let's say it was A plus 2B. So now our ratio is 1 to 2. So if we had 1 mole of A, there'll be 2 moles of B. Or if we had like 7 moles of A, well, it's 1 to 2, so 7 moles of A would mean 2 lots of 7, it would mean 14 moles of B. So it's first part of the question, and I'll go through a couple of practice ones of these. You work out the moles of the known concentration, use the balanced equation to work out the moles of the unknown one, and then moles divided by volume gives you the concentration. So first practice one. It takes Nigel 25 centimeters cubed of 0.1 mole per decimeter cubed HCl to neutralise 30 centimeters cubed of NaOH. What is the concentration of NaOH? So first one we're looking, which is the one they've told us about? This is the concentration of HCl. So we know the concentration of HCl. We are trying to calculate the concentration of NaOH. So concentration of HCl equals moles of HCl divided by volume of HCl. Rearrange that. Concentration times volume equals moles. Remember, we need to divide these by 1,000 because they're both in centimeters cubed. So what is the concentration of HCl? It's 0.1. So we've got 0.1 times by, what is the volume of HCl? 25 centimeters cubed, but we need to change that to decimeters. So 25 divided by 1,000. And I wish I'd have set up my calculator before we started, but I'm using my phone to record it. So I'll just quickly type this into the computer. So 25 divided by 1,000 gives us 0.025, and then times that by 0.1. So we get 0.0025 moles of HCl. We go to our equation. Remember, scientists being really lazy, there are no numbers in front of those, so that means that is a 1 and a 1:1 ratio. So if we have that many moles of HCl, we'll have exactly the same moles of NaOH. So now we know we've got 0.0025 moles of NaOH. The whole point of this, the whole question, what is the concentration of NaOH? So concentration equals moles over volume. We know the moles now, it's 0.0025, and the volume, well, it was 30, but we need, it's centimeters, so we need to change it to decimeters. So we do that divided by that, and we get, where are we? That one divided by, okay, and our answer is 0.083 moles, and I've run out of space. That is moles. Let's do it on a separate page here. Right, 0.083 moles per decimeter cubed. And we can check that answer, or kind of work out if we think it's right. 25 and 30 are roughly the same, approximately. This is just to like check ballpark for our answers. The ratio is 1:1. If it was 25 and 25, then we know the concentrations would be exactly the same, because we've used 1:1 and they were 25 and 25, they were the same amount. But we haven't had to use 25, we've had to use 30. We've had to use more of the NaOH, which means we know the concentration is roughly the same, but it's slightly weaker than the HCl. We've had to use more of it. We've had to use 30 instead of 25. We've had to use more of it, so the concentration is going to be slightly weaker, but in the same ballpark. So we know our answer should be around about 0.1, but slightly less. And we got an answer of 0.083, which is round about 1, slightly less than 1. So that's the first question. Let's try a second one. So 50 centimeters cubed of 2 moles per decimeter cubed sulfuric acid, which is H2SO4, is neutralized by 48 centimeters cubed of NaOH. Calculate the concentration of NaOH. Well, let's just do our ballpark figure. 50 and 48 are really, really similar, okay? But our ratio here is 1:2. So if we'd used exactly the same amount, bear in mind we need twice as many moles of this, we can guess that the NaOH is going to be roughly twice as strong. If it was 50, it would have been twice as strong. So that one was 2 mole per decimeter cubed, so we'd expect this one to be around about 4 moles per decimeter cubed. Is actually, we've had to use even less, so it's going to be slightly above 4. That's going to be our guess, roughly above 4. So we go back to our method of solving it. H2SO4, that's the one they've told us about, which means that's the one we're trying to work out. So we go concentration equals moles over volume, rearrange it, concentration times volume equals moles. We know the concentration is 2, we know the volume is 50, but you've got to remember to change it to decimeters, so 50 divided by 1,000. And that makes our answer 0.1, I believe. So 0.1 moles of H2SO4. That's how many moles we've used in this thing. Then we go here, it's 1 to 2, so the ratio is 1 to 2. So we need twice as much of this. So if we had 0.1 mole of that, we need to double it. So we will have 0.2 moles of H2, 0.2 moles of NaOH. How do we work out concentration? Moles divided by volume. Moles was 0.2 and the volume 48, but we need to do 48 divided by 1,000 because we need it to be in decimeters. 48 divided by 1,000, and I'll just type that into my calculator. Which is 4.17 moles per decimeter cubed. And we go back to our answer. We thought it would be, remember, if it's 50 and 50, same but twice as much. Back to what we said at the start, we were looking for an answer slightly more than 4, and then our answer is slightly more than 4. So to summarise, every single titration question, you will get a solution where you know the concentration and you know the volume. You will have a separate solution over here where you know the volume and that's it. You don't know anything else. And the whole point of the question is for you to work out this concentration. That's what you want to do. So step 1, use these two to work out the moles. Step 2, use the balanced equation to turn moles into the moles of the other one based on the ratio. And then step 3, you can work out that concentration now because you know concentration, you know the moles, and you know the volume. Okay, so the moles into moles one is that's where you use the balanced equation. Like in this one where it was 1 to 2, so we had to turn 0.1 into 0.2. Or in our first question where it was 1 to 1, so we worked out moles and then that just told us the moles of the second. Okay, so work out the moles of the one you know, work out the moles of the one you don't know, and then work out the concentration that you've been asked for.